Meeting rooms 2. This is a premium medium problem. Given an array of meeting time intervals where intervals I has one start time and one end time. Return the minimum number of conference rooms required. So see the examples here. We are given list of intervals. So in the first example we have 0 to 30, 5 to 10, 15 to 20. You see 0 to 30 and 5 to 10 overlaps, right? So we need two rooms there. If you see 5 to 10 and 15 to 20, this don't overlap, but 0 to 30 and 15 to 20, they again overlap. So overall we need two rooms max. And two rooms, this is the minimum number of rooms we need. In the second example, you see there are two intervals 7 to 10 and 2 to 4. So 2 to 4 comes before 7 to 10, right? So 2 to 4 needs one room and it is over at 4. Then that room only we can allocate to 7 to 10 interval. So we just need one rooms, that is the minimum number of rooms we need here. So consider the first example we have. So this is 0 to 30, this is 5 to 10 and this is 15 to 20. So for ease of processing, we can sort the intervals based on the start time. So here the intervals are already sorted in the start time, but not necessarily for every example it will be sorted. So the sorting will take order of n log n. So after sorting, let's see here, this 0 to 30 and 5 and 10 overlaps. So here we need two rooms. Here again we need one room, and again here this 0 to 30 and 15 to 20 overlaps. Here also we need two rooms. 5 to 10 and 15 to 20, this don't overlap. So minimum two rooms we need to satisfy all these meetings. Now let's say we have two intervals A, B and C, D, and I have drawn few scenarios here. First of all, these two intervals are sorted based on the start time. That means A is always less than C. Now, AB and CD will only overlap if CD is starting before AB is ending. That means C is less than B. Then only there will be some overlap. Here also you see CD is starting before AB is ending. That is C less than B. Here C is greater than B. So there is no overlap. One condition here is C is equals to B. That means CD is starting when the AB is ending at the same time. So as per the question here, AB will end first, then CD will start. So this is not a overlap. So if C is equals to B, then also there is no overlap. Only when C is less than B, in these cases there will be overlap and we need one extra room. Now here are a few more examples where we have already processed few intervals. The intervals in green are already processed in all the scenarios, and CD is a new interval that we will process. So these intervals are also sorted based on the start time, that is A1 less than A2, A2 less than A3. Now an interval CD is coming. Let's say C is less than B2 here but greater than B1 and B3. So CD is starting after this A1 B1 and A3 B3 ends, but before this A2 B2 ends. So clearly how many rooms we need for this? So initially without the CD we needed 3 rooms, minimum 3 rooms we needed to satisfy these 3 intervals. But at this point we need 2. But here you see after B3 one room is getting free. This room we can easily give to CD. So we don't need any extra room. After B1 one more room is getting free. So here only one room we need. That room also will remain free, but we don't have any interval here to give. So we don't need any extra room if CD is starting after any of this intervals ends, right? Like here A3, B3 and A1, B1 both ends. In this example, CD is starting before B1 and A1, B1 and A2, B2 ends, but after A3, B3 ends. So here also you see, like after A3, B3 is done, we can give the same room to CD. So we don't need any extra room here. So minimum number of rooms required is also 3 here. In this example, you see CD is starting before any of this interval ends. Like C is less than B1, C is less than B2, C is less than B3. All of the ends are greater than C. That means no room is getting free. So that we cannot give any already occupied room to CD. That's why we need one extra room. So when we need an extra room, when C is less than B3, B3 here is the minimum end. You know, these three intervals we have already processed, and B1, B2, B3, these are the end time, and the minimum end time is B3. If a new interval that is coming, that is starting before this minimum end time, then we need an extra room. So what data structure comes to my mind now? So we can use a heap or priority queue based approach here. So easily we can just store this n times in a heap, and if we can see the new interval that is coming, that is starting after the minimum end, then we don't need any extra room. But if this interval is starting before the minimum end, that means we need one extra room. So here we have one more situation. It's the same thing, like CD is starting when A3, B3 is ending. That means C equals to B3, B3 equals to C. But here A3, B3 will end first, then CD will start. So we don't need any extra room here. Now here consider one more thing. Consider after CD we are processing EF. That is one more interval. So of course all the intervals are sorted based on the start time. That means EF is starting after CD. I mean E is greater than C. E is greater than equals to C, right? So when we need extra room, that is in this last case, in this scenario, right? When CD is starting before A3, B3 ends, or C is less than B3 and B3 is the minimum end. So then we need one extra room. But can you comment anything about the EF? C is less than B3, that we can say, but we cannot say we cannot comment like E is less than B3 or greater than B3. We don't know yet. But consider this two scenario. Here CD for C is greater than B3. We don't need any extra room here. C is greater than B3. Here also C is greater than B3. In both the C greater than or equals to B3. So in all the cases, as E is greater than C, E also will be greater than equals to B3. That means EF, this interval also will never overlap with A3 and B3. Then we don't need to keep this A3, B3 in our heap. We can just get rid of this A3, B3. So that's one small point I wanted to add here. Now, what will be the time complexity for each heap operation? That will be order of log n, and at max, in the worst case, if all the intervals are conflicting with each other, we will be needing an order of n log n, and for sorting we needed a complexity of order of n log n. So overall complexity is order of n log n. See the solution here. These are the intervals. This is one heap that will be populating, and these are the room number, count of rooms we are keeping track of here. So first interval is 0 to 30. we need one room for this, and we'll keep this end time in the heap. Next we are processing 5 to 10. So 5 is less than 30, the minimum end we have in our heap. That means there is an overlap. So we need to increment our room count. After that, we'll push this end time 10 into our heap. So the heap will be like this, 10 and 30. Minimum will be 10. Next we are getting 15 to 20. So 15 is not less than 10. 10 is a minimum end here. 15 is not less than 10. That means we don't need any extra room. So we can just keep the room count to 2 itself. Now what we can do, this 10 we don't need to keep track of, we need to keep this 10 into our heap, because no further intervals, we don't have any further intervals here, but if we had, no further intervals will overlap with the interval that is ending at 10. So we can just pop 10 and push this end time, push 20. So our heap will become 20 to 30. And we end here, and the maximum number of rooms you see in the room count is 2, right? So our answer will be 2. I have taken one heap. Here I will be storing the end of the intervals. So to start with, I will add the end of the first interval 0, 1, that is the end of the first interval. Next, I'll just go through the next intervals starting from 1 index to length of intervals. So what I have to check, if this intervals of I dot 0 less than heap of 0, in that case what we will do, we need one more room, right? So let's take one rooms variable. So initially we added one end index end time, right? So we need one room for that, and every time we are getting one intervals whose start time is less than the end time that is at the top of the heap, I'll just increment the end counter, room counter. Otherwise the current interval is starting after the end interval at the top of the heap. So we can just remove this, remove the top element from the heap, and then in both of the cases we will be adding this intervals, current intervals and time. So heap q dot heap push heap and intervals of I1, right? So that's it. We can just return the rooms. This works. Let's submit this. And this is sufficient, but let's try to improve this. Okay, so the next improvement, here we are taking all the time slots, like 0 is the start time, 30 is an end time, 5 is start time, 10 is end time, and so on. So all times with the type start or end. Then we are sorting the times, and let's say 0 with start, then came 5 with start, then 10 with end, and 15 with start, then 20 with end, then 30 with end. So we got it sorted based on this time. Now this is we are taking one count variable that is for the number of room. What it means is, at 0 we started one meeting, so we need one room for that. At 5 we are starting one more meeting that needs one more room, because we have not ended any room, so we need to increment our room count. Next, at 10 some meeting is ending, that's why we are decrementing the count. So that 15, again one more meeting is starting, so we have to increment our count. At 20 we are ending one meeting, so we are decrementing. At 30 we are ending, so we are decrementing. So if you take all the counts, the maximums are all 2 and 2 in this case. So we need minimum 2 rooms to satisfy all these meetings. So what is the time complexity for this solution? So for sorting, we anyway need order of n log n. But here we have n intervals, and considering each start and end time, we have 2n number of elements here, and we are going through it once. So this time complexity, this processing time complexity is order of 2n. So we'll see a different solution later where instead of 2n we can just have a order of n complexity in this processing. Okay, this is a quick approach. Times is, let's say, intervals of 0. This is for the start times I'm taking, and I'm just taking one tuple. So this is the start time. To indicate that it is a start time, I'll just taking start here, or let's say just take s for simplicity. For interval in intervals, right? Similarly, I'll just take the n's. This will be n time, and to indicate it is AE, and I'm just adding it in this same list, right? So this times list will have the time and the indicator whether it is a start time or the end time. Next, I'll just sort this, right? After sorting it, I'll just take one rooms variable and one total rooms variable. Next, I'm just going through the times. And if times of I and I1 equals to start, that means we are starting this is a starting point for any meeting, right? So we'll increment the rooms counter, and otherwise will decrement the new rooms counter. So when we are incrementing the news counter, that time only we can just update our total rooms. That will be max of total rooms and rooms. That's it. We are done. We can just after this return total rooms. Let's run this. This works. And it is okay. It's an okay solution. Let's try to improve this. So here comes our final improvement. This is a slight improvement, but that makes some difference. So this is our same intervals, but we are taking start and end variables end times separately. 0, 5 and 15, these are the start time. 30, 10 and 20, 30, 10 and 20, these are the end times, but I have sorted this. This sorting will take order of n log n, order of n log n, that means total order of n log n. And we are taking the count variable, so that is for the room count at each time. So what we are doing, we are taking one variable I, variable j, these are the index for start and end. So what we'll do, at initially I and j will point to 0th index. Now at 0th index we see one meeting is starting at 0 and one is ending at 10, right? So that means the start time is less than the end time. That means we need to increment our room count, and also will increment our ith pointer. Here also we see start of I is 5, end of j is 10, start of I is less than, that means at 5 also something is starting. So we have to increment our room count. I also will increment our I. Here we see start of I is greater than end of j, right? So that means there comes a 15 event that is starting after this end time. So in this case we can decrement our room count, And what we can do, we can increment our j. Now j here will become, just end of j will become 20. Now start of I is 15, end of j is 20, 15 is less than 20. So we got, that means we have to increment our room count again. And also this 20 we have to insert, right? 20 will insert here. So after this also will improve our I pointer, so it will go out of bound. So again we have to compare the thing, right? But here's one thing, when we have exhausted our start times, we can stop our processing, because we should increment our room counter only when some interval is starting, meeting interval is starting, right? Then only we may need some extra room. But if some, at the time when some event is ending, that time we don't need any extra room. So as soon as we will exhaust our all start times, we can stop our processing. And the minimum of and the maximum of all these counts will be the minimum number of rooms required. Okay, we are taking the starts list, that will be intervals 0 interval 0 for interval in intervals, and the ends list, that is interval 1 for interval in intervals. And I'll just take the sorted version of this two list. We are just sorting this two. Done. Now next I am taking two variable I and j for to look through this starts and ends list. And just like earlier, we needed rooms and total rooms. Both are initialized to 0. Next I am going through the starts list. Basically I less than length of starts. If starts of I less than ends of j, that means we have to increment the room count. Room plus equals to 1 and I plus also equals to 1, because we want to increment our I pointer, and here we have to update our total rooms, right? Just because here we are incrementing the rooms count, here only we need to check the total rooms required, total rooms and rooms. Otherwise we'll increment j pointer and we'll decrement the rooms count. That's it. Here we don't need to update the total rooms, because we're just decrementing the rooms count, and that's it. We can just return the total rooms. It works, and this is pretty efficient.